In the name of God, today we want to speak about the antigen-antibody reactions. In this session, we speak about different definitions in antigen-antibody reactions, and also we become familiar with different laboratory methods which are based on antigen-antibody reactions. I'm Samira Rajai from Department of Immunology. The outlines of this session are these outlines: basic definitions in antigen-antibody reactions, zone of equivalence, cross-reactivity, methods based on antigen-antibody reactions, ELISA, radioimmunoassay, Western blotting, flow cytometry, IHC, and IF. You know that each monomer of antibody can recognize antigens by two antigen binding sites, and the interaction of antigen-antibody involves non-covalent reversible binding. Different bonds, such as hydrogen bonds, electrostatic bonds, van der Waals forces, and hydrophobic bonds, could be involved in interaction of antigen and antibody. And the most important issue is that the reaction of antigen and antibody is reversible because these bonds are not covalent. We have two definitions in reaction of antigen and antibody. The first one is affinity and the second one is avidity. Affinity is the strength of the binding between a single combining site of an antibody and an epitope of an antigen, and we name this strength as affinity of the antibody. So if we speak about affinity, we have an epitope on the surface of the antigen and a paratope of the antibody, and the interaction of an epitope with a paratope is called the affinity. So the strength of binding of an epitope and a paratope is called affinity, and we represent the affinity with a constant which is called dissociation constant, or Kd, and Kd indicates how easy we can separate an antigen antibody complex into its components, and generally a smaller Kd or a smaller dissociation constant indicates a stronger or higher affinity interaction. The second definition is avidity. You know that in many instances we have dimer or pentamer antibodies, and also we know that in monomers of antibodies we have two antigen binding sites. If we have an antigen and an antibody, the overall strength of attachment of an antigen to an antibody is called avidity, and this avidity is much greater than the sum of affinities of all antigen antibody sites. Avidity depends to different factors. First of all, the avidity is depend to the affinity of the antibody for the epitope. But beside the affinity, we have two other factors. The second one is the valency of the antibody or the antigen. The valency means the number of antigen binding sites which are present in antibody, or the number of similar epitopes which are present in an antigen. And the third factor is the structural arrangement of the parts that interact with each other. Here you see in the first section you see a monomer antibody and an epitope of an antigen, and you see that this monomer could interact with the epitope, and then this binding could be detached, and the antigen can separate from the antibody, because we said that the antigen-antibody interaction is reversible. In this part, you see a polyvalent antigen or multivalent antigen. If we have several similar epitopes in an antigen, we name that antigen as a multivalent antigen or polyvalent antigen. And you see that this monomer antibody could interact with two similar epitope in the structure of the multivalent antigen, and also it can separate from this antigen. So in the first picture, we can say that the interaction of the antigen binding site and this epitope is called affinity. But in the second part, we have a multivalent antigen and the interaction of antibody with two antigen binding site with this multivalent antigen. The interaction of this, the strength between this antibody and this polyvalent antigen is called avidity. Here in this picture, we have 4 columns, and in the first and second column, we have affinity. You see here that in the first and in the second column, we have only one epitope. In the first column, we have Fab region of the antibody, and in the second column, we have IgG. But because we have only one epitope, the interaction of this IgG with this one epitope is called affinity. So if we have one epitope and one antigen binding site, the interaction means affinity. But in the third and fourth column, we have IgG and IgM, a monomer and a pentamer antibody. And also we have multivalent or a polyvalent antigen. You see we have several similar epitope in the structure of this antigen, and the interaction of the IgG with this multivalent or IgM with this multivalent antigen could induce avidity, and the overall strength between an antibody and a multivalent antigen is called avidity. And you see that these avidities are much greater than the sum of the affinities of each of them, and we have more strength forces in when we use avidities. Here you see 3 pictures. In first row, we have a multivalent antigen. You see the similar epitopes on the surface of an antigen, And we also have a monomer antibody like IgG, because the epitopes on the surface of the antigen are far from each other. The IgG could not involve both of its arms to interact with two epitopes. So the interaction of IgG and the epitopes of multivalent antigen is a monovalent interaction, and the avidity of this interaction is low because the epitopes are far from each other. But in the second row, you see that the epitopes are nearer to each other, and you see that IgG can use both of its antigen binding site. So we have a bivalent interaction, and the avidity of the interaction increases. And in the third row, we have IgM, and IgM, you know that is a pentamer immunoglobulin, and the IgM can use 10 antigen binding site, and also we have a polyvalent antigen. So the interaction of IgM with this polyvalent antigen induce a polyvalent interaction, and the avidity of the interaction is very high, and is higher than the second or the first row of this picture. So the structure or arrangement of the epitopes on the surface of the antigen is important in determining the avidity of the interaction between the antigen and antibody.